So, good afternoon, everyone. Welcome to session 2 of day 3 of our faculty development program. So, today I am honored to welcome our chief guest, Mr. Jay Prakash Gupta. Welcome, sir.
Thank you, madam.
He is working as a scientist at Scientific Analysis Group DRDO. He completed his BTech in Computer Science and Engineering and has over 21 years of experience in project and research. He has extensive work experience in IP traffic analysis, analysis, IoT, SDN, AI and network security, cyber security and threat security and automatic identification of the network. From the past 3 years, the primary focus is towards the QST, quantum key distribution, and he is also interested in many topics like the quantum cryptography, finite key analysis, optical communication, and the optical simulations. And he has also delivered many lectures regards the new technology. Now he is interested to share his knowledge in FTP program regarding the AI systems, secure networks and QST. It's a great privilege, sir, to have you with us today. We are looking forward to learning from your valuable knowledge. Now I request Vice Principal Academics, HOD of EC Department, Professor Kirti Gupta, to kindly come and felicitate our chief guest.
Thank you. Thank you. Thank you.
Thank you, sir. Thank you, ma'am. Now, I warm welcome to Mr. Jay Prakash Gupta to kindly take over the session. Thank you, sir.
So, thank you, madam. So, I think my introduction has become a bit heavy. Okay. So, I have not delivered many lectures. So, only some lectures inside my office I have given. So, for the last 3 years, I am working the quantum key distribution system. So, I want to thank Madam Kirti Parsuram sir for inviting me here. So, today I am among the teachers. So, I will see, you will judge me whether I am pass or fail after this session. So, so let's come to the topic, quantum key distribution, a comprehensive overview. So, I have prepared these slides keeping the mind for all the participants. I am not especially prepared for the specialist people like you, madam. So I will be giving the general overview and some glimpse of the work which we are doing because of the organization policies. So I will not be showing our implementation, some implementations. So kindly pardon me for that. Okay. So the outline of my talk will be the motivation. What is the motivation for the QKD system? Why we are looking for the QKD system? Then the QKD introduction, the various components, technology, communication media, all these things we will be seeing in the quantum QKD introduction. Then the core concepts, principles, quantum mechanics principles, then protocol and attacks, which protocols are prominent in the commercial domain right now within India and why we are focusing on those protocols. So right now we are having the coherent one-way cow requested DPS systems which are coming into the market. Many private players are developing these systems, specifically the DPS and cow. The government company like the CDOT, they have developed the system for the cow and DPS. Many startups like the QNU Lab, QDate, TechBit, they are also developing these systems, and measurement device independent and the twin field, these are the futuristic protocols. Very soon these products may come into the market. Okay. Then we will see some aspects of the free space quantum key distribution. Then the major security concepts. Actually, I come from the SAG, Security Analysis Group, which is under DRDO. We are looking mainly for the security evaluation aspect of the security systems, like the new technology, the QKD. So we very soon the systems will be coming to the market. So we have to analyze the security of such kind of systems. It's hardware security, software security, and the protocol security as a concept. Then I will be discussing about some other important aspects of such kind of system, and finally the conclusion. So now coming to the motivation, as we all know that quantum computers are coming to the market in a big way, and the algorithm like the source, they are getting the advantage from the quantum computer, and some problems are getting affected through the advancement in the quantum computers like the RSA, Diffie-Hellman, and ECC. These protocols are public-private key cryptographic system which are mainly used for the key distribution between two parties. So that's why to solve to secure our systems, the two-pronged strategy is being followed. First one is the post-quantum cryptographic scheme. Second one is the QKD. So the RSA, Diffie-Hellman, ECC, these are all based on the mathematics principle. So that's why they are under the threat due to the advancement in the mathematical systems or the quantum computers. So the first one, the post-quantum cryptography, again these problems are based on the mathematics principle, but these are the quantum resistant for now. For future we can't say. It may be someday some attack may come into the these problems. So the new approach is the QKD. It is saying that we will generate the key using the quantum mechanics principle. Actually, altogether the plane has shifted from mathematics to the physics. So the mathematics based approach may not work here, will not work here. But we have to see how much these kind of systems are secure. The question is this, because the quantum mechanics principle mostly they are stable and they are not for the time being they are valid. We can't say for the future for after 100 years, 200 years, because the physics principles also get changed. But we have to see based on these if the quantum mechanics principles are valid also, how much we can secure a system, what are those deficiencies in the system which can break our system. So our job is to see from all these angles. So we will see in the slides how much secure is the QKD systems. So now coming to the basic introduction of the QKD scheme. Suppose there is user A, it wants to communicate to the user B. Suppose I am the user and I want to communicate to the sbi.co.in. In that case, we need a key which is encrypting my message from my end to the server end. So how this key is being established, it is the main thing. So right now it is being established using the RSA, ECC, or Diffie-Hellman. So we are trying to shift this key generation process from the RSA, Diffie-Hellman, ECC, all these things to the QKD system. So we will place the QKD system here, which will provide the key to the user A and user B, and they will communicate using this key. So this key generation process is the QKD system. So here we are having the two channels, quantum channel, classical channel. Through quantum channel, the quantum information flow from the LS to Bob end. Here is the laser which is sending the light in a very weak manner, WCP, weak coherent pulses, and these pulses are getting detected at the detector and Bob, and finally through the classical channel they are communicating for which pulses they have got the click. They are also discussing if any error is coming. So there are many steps. So we will see in future next slides. So ultimately the key is being established between user A and user B, and finally this is doing this communication. But here are some core assumptions, like the quantum channel. We are having the core assumption that this is untrusted and may be completely controlled by an Eve. In the classical communication, it is authenticated and integrity protected. Without this, the QKD system will be under will be compromised. So this is the main assumption which we are following here. So if we say that QKD is ultimately absolutely secure, it's not. Under some assumption, it is secure. So now coming to the sample QKD simulation implementation. So the people who are not from this background, they can have the understanding of this kind of system. So we are having the LS and the bob. From the LS side, there is one laser which is sending the pulses, continuous wave laser. But whatever key we want to send, we are having a random number generator. So randomly it will generate the key. This is the 1010 form, but we have to make the pulses. So we are using the pulse generator. So based on this number 01010, so the pulses will be generated, and these pulses are the electrical pulses. This is the optical thing. So these electrical pulses will be modulated into the optical form, and finally the optical output will come out from this Mach Zehnder modulator. Now we are having some suppose 10 milliwatt laser, and the frequency of this pulse generator is 1 gigahertz, and one photon is having around 10 to power minus 19 joule power. So in that case, each pulse will be having around 10 to power 8 photons. So if we float 10 to power 8 photons from on this channel, then the very important attack, that is the PNS attack or the beam splitter attack, it may come into the picture. So we have to make a single photon per pulse. This is our ideal condition. We have to achieve the single photon per pulse, but it is not easy to achieve the single photon per pulse because of the Poissonian nature. So we have to attenuate these pulses. Huh. Beam splitter we can use. Optical null. 50 30. So in that case you can use. So beam splitter also comes into some ratio, na 90:10. So we can use that kind of thing. Changeable. It's changeable. It's changeable. So actually this coupling coefficient in the standard cow protocol, it's 0.1. So this is the simulation of the cow protocol. I am just for the simplicity I am showing this thing because this is simple protocol. So whatever the pulses are coming here, so the 90% will go to the data line. This data line will generate the final key. 10% will go to the monitoring line. Through this monitoring line, we will identify whether any attack has happened or not. Or so okay, so that question I'm not sure. Okay, actually we have seen from some implementation, so we have used or we can use direct also. So this is we can replace it with the direct line also. It's not something like the fork we are required here. So around 0.5 50% pulses will come into this path. Here it will do the 1 bit delay, and they will interfere those pulses. And for the higher consecutive, the theory is that for the higher consecutive pulses, we should get the detection at the one detector. For those higher consecutive pulses, we should not get the detection at the DM2. In case if we are getting the detection at the DM2 also for those pulses, then in that case the visibility index formula will come to the below the threshold. In that case, we have to drop the communication. So this is we will see in the cow protocol. It's a detailed thing, but for the simplicity, we are having the laser, then the Mach Zehnder modulator, then the optical attenuator for making it the single photon pulses, and finally at the detection end, we are having the detectors, SPD, single photon detectors. So finally, we are doing the data recovery. So this is the quantum process. Up to here, this is the quantum process. So as we have seen in the previous thing, there is the classical channel also. So whatever the data will be received here, now we have to process in through the quantum channel and classical channel, and we have to receive get the final secure key. So we will see the all those steps in next future slides. So now for the simplicity, for the person who are not from this background, these are the important components that like the transmitter, receiver, quantum channel, classical channel. Generally continuous wave lasers we use it in the transmitter end, and it generates the random bits, encodes them into the quantum states qubits. Bob receiver measures incoming quantum states, use protocol specific measurement setup. In the quantum channel is used for the transmitting the qubits. The quantum channel may be optical fiber, free space communication link, or the satellite link. And through the classical channel, we do the time synchronization. Whatever the bit we have sent from the LS end, the same bit has been received at the Bob end. How we will be sure? In that case, the time synchronization is playing the major role. Then the basis comparison, error correction, and the privacy implication we are doing for to get the final secure key. So the Bob side detector technology, we are having different kind of detector technology. Each are suitable for some kind of application, like the silicon SPAD based technology. It is not suitable for the 1550 telecom fibers. So that's why we don't use in the fiber domain. In gas SPAD, this is for the practical telecom fiber QKD. SNSPD, it is a very high highest efficiency, lowest noise, lowest jitter. So in cases where we are getting very low key rate, in that case we use the SNSPD to get some usable secure key rate. So the silicon wavelength, silicon SPAD is better in the range of 400 to 1000 nanometer. So it is being used for the fiber free space communication, and in gas SPD SPAD is being used for the fiber. Detection efficiency, here we are having the 60 to 80%. In the fiber domain, only 10 to 30% we are having. SNSPD is having the 95% to 99%. Whatever the photons which are incident on it, it will detect 95 to 99%. The dark count means whenever we are not having any photon, even in that case, our detector is so sensitive that it will say, okay, I have received some bit. So dark count means false incident of the photons. It's very low in case of silicon SPAD. In gas SPAD, it's moderate, and for the SNSPD, it's extremely low. Timing. So SNSPD is the best technology, but it's coming with the cost. We systems are coming around 2.9 crore, 2.8 crore. So it's very costly. This is 25 to 30 lakh. So it's being used in the commercial domain. The people are using this detector. So for the free space and the satellite based technology, we are using generally people are using the SNSPD to get the enough key rate. So now coming to the communication media, we are having the fiber or the free space. So fiber, it is best for the fixed terrestrial networks. Free space, satellite, and line of sight links, we are using the free space communication. Distance, it's less in this case because we are having the loss 0.2 dB per kilometer for the fiber. In free space, when we are having the terrestrial link, in that case the loss is much because of the environmental factors. when we try to do the satellite communication, because the atmosphere is only 10 kilometers, so in that case we are getting the larger coverage. So weather sensitivity is very low in case of fiber. Free space communication, we are having the high weather sensitivity. Whenever diffraction will come or fog is there, then it will adversely affect our communication. Installation, it requires the fiber infrastructure. The minimal in case of free space, minimal infrastructure, but optical terminals are needed in this. Mobility, no, here is the mobility. We can get the mobility here. Commercial maturity is very high in case of free space fiber, because in commercial domain, as I have told you, that we are getting the many QPD systems into the market. Mobility means, madam, suppose satellite communication, we have, for the military communication, suppose, so the ground station can move, because it's a pointing and tracking, all those things, so it can move. So for future, it's actually coverage is very less. So for the future, we have to move towards the free space or the satellite. Satellite is the ultimate objective, because it will give us the global quantum internet coverage. So who are the users for this kind of technology? This is actually, these systems are costly right now. So the major users are the big banks, data centers, government networks, military domain. For the mm, mm, for the free space, major users are the defense communication, airborne platforms, ship-to-ship tanks, links. So inter-island communication. So free space is mainly for is giving the coverage for these kind of applications. So this is just for the qubit basics. A qubit is combination of cat 0, cat 1 with the probability, and the probability is alpha square beta square is equal to 1. So using this principle, the qubits are being generated at the LS end and sent towards the bob end. So this is the basic protocol BB84. Bennett and Bessard 1984, they have given this protocol. So they are generating the qubits in two bases, rectilinear basis or the diagonal basis. For the simplicity, for the understanding, we can think that suppose this is the Hindi speaking person, it is Chinese speaking person. Whenever it and Alice is having the Hindi and Chinese both speaking person, and the Bob is also having the interpreter for the Hindi and Chinese. So whenever the Hindi message is coming, then the Bob will understand properly. It will give the 100% result. If the Chinese message is coming, and here we have employed the Hindi person, then in that case, suppose Chinese language is written and we have to give the answer in yes or no, then in that case we will not be able to give the proper answer. So we will get the random output. So different polarization we are using here, D, diagonal, anti-diagonal, or the horizontal, vertical. So finally, this is the BB80 protocol scheme and how the final shared secret key is being generated. We have to see this thing. Suppose LS is sending 0, 1, 0, something like this way, and its random basis is X. So in this case, it has to map to the previous truth table here. For the X, if it want to send the bit 0, then it has to send the polarization D. Okay. If for the X basis, if it want to send the 1, then it has to send the bit in the polarization pulse in the polarization A. So sorry. So when it wants to send the X, when it is having the X basis, then it will send for this random bit 0, it will send the photon polarization in D diagonal angle. And at the Bob side, if the basis is matching in that, because here it is using the X basis, at the x basis it is measuring, so it will get the exact value d, and the d is corresponding to 0. But here it is sending the in plus basis, and it is receiving at the x basis. It's sending the Hindi message, but it is interpreting in the Chinese. It means it will give the garbage output. In that case, when the basis is not matching, we discard those bits. So in this way, wherever the bases are matching, we are generating the secret key. Finally, and the basis where we are not, where the bases are not matching, in that case, we are not generating any key. So the 50% key are almost discarded here. So this was the quantum process. Up to here, we have got the shared secret key through the quantum channel. Now coming to the Alice and Bob, they have communicated through the quantum channel, and they have got this key, shared secret key. Now this key, it has to undergo some process at the Alice and Bob end to get the final secure key. So whatever the raw key we have got, we have applied the shifting process. After shifting process, we have got the shifted key. So so this was the shifting process, because we have matched here where the bases are matching, and we have got the, so up to here the shifting process was completed. So after shifting process, we have got some key, but this key may not be matching it at the Alice end and the Bob end. So there is some errors. So now we have to estimate the error, how much error we are getting. If it is beyond a threshold, then we have to discard this communication. If it is not beyond a threshold, then we have to do the error correction. So how we will estimate the error? We will disclose some amount of the key, like the 3%, 10%, and with those, so Alice will share the 10% of the key with the Bob, and the Bob will also share the 10% of the key with the Alice, and both will estimate the Q bar at their own end. After that, if it is within the threshold, then they will move to the error correction, otherwise they will stop the communication here. So in QKD, we are not saying that we will not get the error. We will get the error, but we have to detect the errors. Then it is coming to the error correction process. So error correction process, many error correction schemes are there, like the LDPC. So we will do the error correction through those schemes. And finally, whatever the key we are getting, through error correction also some key may be exposed to the, some portion of the key may be exposed to the E. So how to suppress that information? We are doing the privacy amplification. In this, we are randomizing the output, and finally we are getting the secure key. We are compressing here also. Based whatever the error we are getting, based on the error, we have to suppress the key, compress the key to get the final secure key. So now coming to the QQT protocols classification, we can classify protocols based on the architecture or based on the encoding decoding strategy. Based on the architecture, we are having the prepare and measure and the entanglement. In prepare and measure, we are preparing some qubits at the LS end and sending towards the Bob end. So under this category, prominent protocol like the BB84, cow, DPS, MDI, twin field, all these comes into this. For the entanglement, we are generating the entangled photon, and we are sharing with the LS and Bob. So one is measuring, though then the other photon will come in, other party will come to know the value of the other end. So under this, the BBM92 is the prominent protocol. It is being implemented in the free space satellite domain also. Then based on the encoding decoding strategy, here we are using the discrete variable. So we are embedding, encoding the information in form of polarization, time bin, phase. Polarization, as we have seen, BB84 is the protocol. For the time bin, cow is the protocol. Phase, DPS is the protocol. Again, MDI is the polarization based protocol. TF is again phase based protocol. and here we are having the continuous variable CBQD. Here we are counting photon, we are counting the photon. Here we are using the continuous value of the pulses, the wave. But the TRL level, technology readiness level of this section is very high. So that's why the systems which are coming to the market of are of this category, discrete variable. For this category, the TRL level is not that much high. It is very noise sensitive, so the products are not coming. It's in laboratory domain, and it's their range is also very low. But the speed is high in this case. Here the speed is less. Here the speed is high. So together all the protocols combination we can envisage that we will have the global internet, quantum internet sort of thing, because each has its own advantage, disadvantage. So now coming to the core assumption in the QKD, as I have told that the quantum channel is fully untested and may be completely controlled by an eavesdropper. Right now, what is happening in the classical domain? Suppose some communication is coming, some communication you are using internet. Somebody is tapping your internet, so you will not come to know if anybody is tapping this communication or not. But in case of quantum communication, we are saying that if anybody is tapping the communication, anybody is interacting with your communication, then in that case, we will come to know, in that case, we will drop the communication. So devices, here we are assuming that devices used by the legitimate party are characterized and trusted within known imperfections. We are not saying that they are ideal, but whatever range they are operating, we are knowing those things, and we are knowing the imperfections. We have the model the devices, so that whatever the Q bar is being generated through this communication, we are sure, okay, this communication is because of this error is because of the device imperfection. It is not because of the Eve's activity. And one more assumption is there: any eavesdropping attempt introduce detectable disturbance. If there is any new scheme which is not introducing any detectable disturbance, in that case this QKD principle may fail. So whatever the detectable, yeah, madam, it depends on protocol to protocol. It depends on protocol to protocol. I will show in future slides. For the BB84, it's around 11%. Cow protocol 23.8% is the maximum value. With 23.8% Q bar, you will not be able to receive any secure key rate, because whatever the Q bar is coming to mitigate that Q bar, whatever the randomness you have acquired through the process, it will be lost. So we will see in that actually this is finite key analysis domain, and the people have worked out various formulations, and many formulations are there. So I have used one of the prominent formulation. So again, QKD, and it depends also Q bar, how much Q bar you can sustain, how much block size you are taking. If you are taking the infinite block size for generating a key, then in that case the Q bar sustainability will be some different. If suppose you are using only 100 bits of the block, then the Q bar sustainability will be again. So QKD aims to provide security fundamentally based on the physics. Mathematical provable security. Mathematical provable security means we can, through mathematics, we can prove this our system is that much secure. How much secure? This is called the epsilon security. This principle comes, and independent of Eve's computational power. Whatever may be the Eve's computational power, our system will be should be secure up to some limit, provided the assumption of the security proof hold. So we will see these two concepts, security proof and finite key analysis, in later slides. So these are the core quantum mechanics principle First one is the Heisenberg uncertainty principle. As we know that the delta x and delta b should be greater than h by 2. So this principle is being applied for in different contexts. So these are the conjugate variables values. So photon number and the phase are also the conjugate values. So if we try to measure a photon number in a pulse, then the phase information will be disturbed. So with this disturbance of the phase information, we will get the effect in the Q bar, we will get the effect in the visibility index. In the no cloning theorem, this is the second principle which is saying that unknown quantum states can't be copied perfectly. If somebody is trying to copy and regenerating it, then it will introduce some Q bar, and because of this Q bar, we will come to know there is some disturbance and we have to drop the communication. Superposition, unless measured state can't be stated perfectly, and entanglement detects tampering. So Eve can't copy, no cloning. Eve can't measure perfectly, uncertainty. Measurement change states, superposition. Suppose somebody's Eve is in between, it is intercepting and descending. When it is intercepting, it will intercept. But at the time of resending, the 100% information is not has not been absorbed by that person, has not been got that by person. So some Q bar will be inherent Q bar will be introduced in the system. So with this Q bar, we will come to know there is some disturbance has come. So now coming to the QKD ideal device values and the practical parameter values. So under these ideal values, we are saying that QKD systems are perfectly secure. If we are having the practical value, practical typical values, some imperfections, in that case, some inherent Q bar will be there. If it is beyond that inherent Q bar, then we make sure that this is because of Eve's activity and we have to drop this kind of communication. So the mean photon number, it's saying that the single photon per pulse should be there. Single photon per pulse, it's not easy to get single photon per pulse. So how to get this thing, because the single photon lasers are not possible, are not available in the practical domain. So this is very tough problem. So for to get the single photon, we are mean photon number we are generating, it should be 0.1 to 0.6. So suppose we are having the mean photon number 1, then in that case we will be having the multi photon pulses 25%. In case of 0.5 mean photon number, we will be having the multi photon pulses 9% and 0.1 0.5%. So multi photon pulses are the killer of the security of the QKT system. Whenever we are having the multi photon pulses, then those kind of systems can be attacked. मल्टी फोटॉन पल्सेस मीन्स ऐसा है कि सपोज आपके पास एक पल्स में 10 टू पावर 8 फोटॉन्स जा रहे हैं. अब ये 10 टू पावर 8 में किसी ने एक आपका ले लिया, तो उसके पास भी सेम इन्फॉर्मेशन होगी, जो जा रहा था उसके पास भी सेम इन्फॉर्मेशन है. सपोज बॉब के पास, एक सेकेंड, आपका कोई पल्स है, अब उसमें 10 टू पावर 8 फोटॉन्स जा रहे हैं. अब ए जे यू मैंने कुछ फोटॉन्स आपके ले लिए, वो फोटॉन बता रहा है कि उसमें वैल्यू 1 है या 2 0 है. द सेम वैल्यू E will also get and the detector will also Bob will also come to know. So the same key E will also inferring. So in that case, so the multi-photon pulses are the killer of the security of the QKD system. So we have to minimize the multi-photon pulses. To minimize the multi-photon pulses, we have to keep the mean photon number around 0.1 to 0.6. So these how many photons will be there? So it's based on the Poissonian principle. So when we calculate, it's the mean photon number, it's the n, how many number of photons, suppose it's a 0 photon. So, suppose we are targeting the mean photon number 2. So, in this case, the vacuum pulses will be around 13.53%, single photon pulses will be 27%, and 2 photon pulses will be again 27%. So, this 27% is a very huge number. So, the 27% of the key can be directly inferred by the E, and the more than 3 photons will be 32%. So, again this is the killer of the security. So, this kind of system is very unsecure. Now, coming to the mean photon number 1, again here that we are having the 2 photons 18% and 28%, it means 26% photons we are having more than 2 photons or 2 photons. So, the 26% of the key can be taken by the E. So, we have to avoid such kind of high mean photon number. We have to come into this range 0.1 to 0.5. Suppose we are having the mean photon number 0.1. In this case, we are only revealing the 0.47% of the key to the E. We may reveal, not much. But in this case, suppose we are having a 0.1, so the most of the pulses are having no photons. So, when we are not having no photons, it means the key rate will drop. So, this is the main limitation of the key rate in QKD domain. Because we are operating in a very low range of mean photon number, so the only key will be generated through the 9%, or it's depend on the protocol to protocol. Cow protocol, it's a combination of the 2 bits, 2 pulses. So, the same way the channel loss is the again ideal value should be the 0, but for the fiber domain we are having 0.2 dB per kilometer. Because of this thing, it limits again the key rate, distance it's limiting, extension ratio, it means suppose we are saying some pulse is 1 or 0. If we are saying some pulse is 0, so how much 0? So, we have to drop 0, we have to get the extension ratio should be infinite, but here we are having only 20 to 40 dB loss there. So, pulses are not properly on or off. Suppose it is its value is high, suppose 1 dB per 1 dB loss is there. It means 0 means it's not the exactly 0, it's above the 0. So, in that case, we will not be able to identify whether this is classify between the 0 and 1 properly. The dark count rate ideally should be the 0, but it is having some inherent values like the 200 CPA count per second, 800 count per second. It is depending on the detector to detector technology. In case of SPAD, it's coming around 800 CPS. So, if there is no photon also, in that case also we are getting the false clicks which lead to the Q bar increase. The timing jitter, it should be the jitter should be 0, but we are getting some jitter. Because of this thing, the time bin overlap and detection errors will be there. Detector efficiency, it should be 100%, but we are not having the 100% efficiency in the actual detectors. In SNSPD 95%, for the SPAD it's 10 to 30%. Because of this thing also the key rate decreases. Dead time ideally should be the 0, but the detector takes some time to get back to the normal state. So, it's again limiting the maximum count rate, it's again limiting the key rate. And after pulsing we should be having the 0 after pulse, but we are in fact we are not having. So, the false count leads to the Q bar increase. Because of all these imperfections, we are getting the inherent Q bar in our system. So, QKD is saying that we should, whatever the practical values we are having, we should be ideally we should have the ideal model for that thing, so that we can come to know, okay, this much Q bar is expected from this kind of system. So, this is because of the system imperfection, not because of the Eve activity. Otherwise, the Eve will be Eve will hide itself behind the Q bar. So now coming to the protocols and attacks. So as I told you earlier, said that we will be discussing about the cow, DPS, MDI, and twin field, and then we will be discussing some prominent attacks like the beam splitting, interception, and the sequential attack. So now coming to the attacks categorization. Attacks are of two types. Some attacks which are having the impact on the Cuber, we are getting detection for those attacks in form of Cuber, visibility index, loss pattern. Uh, but some attacks which are not having any effect on the Cuber, so they may go undetected. For these kind of attacks, we should have the proper countermeasures. Otherwise, these these attacks will go undetected and it will harm the security of our system. So in this case, we are having the defense like the shielding, isolator, circulator, etc. For these kind of things, we have the option for the design of the better protocol. So in this domain, for the better protocol design, people are moving from the cow, DPS, then the MDI, twin field, then the device independent. So now coming to the cow protocol, it's a coherent one-way protocol. We are having the CW laser here. We are doing the intensity modulation here, and then we are sending on the quantum channel. So here every qubit is the combination of the two pulses 0 alpha. It's showing the qubit 0. One pulse we will count alpha 0 when we are having the higher pulse at the initiation and the vacant pulse at the second slot. We are having the vacuum pulse at the first slot, we are saying it's 0. Here we are having the alpha, it means it's the filled pulse. If clicks at the both the end, then it is called the decoy pulses. These decoy pulses are not meant for the key generation, they are only meant for the monitoring line, for the detection of the any attack. If there will be any attack there, then in that case there will be change in the pattern of these alpha alpha, and we are measuring to the visibility index formulation. As I told you earlier, here what is happening, we are having the coupler here, so we may have the 50-50, 90-10. So the 50% will go to the data line, 50% will come to here, and whatever the pulses are coming here, we are interfering with the 1 bit delay. And for the higher consecutive pulses, the detection should be at the DM1 and it should not be on the DM2. If we for the higher consecutive pulses we are getting at the DM2, it means our visibility index value will come below the threshold. Generally, its value is around 0.85. Cuber is around 5%. So with the combination of Cuber and visibility index, we decide whether we should discard a communication or we should continue with the communication. So now, as we have discussed it earlier also, this is the cow implementation I have shown earlier. So now we will come to the data part. So for the simplicity, here we are using the mean photon number more than 1. So right now we will see how the pulses are, how we are identifying the pulses. So 50 to 51, this is one slot. 51 to 52, this is second slot. So 50, it is the low pulse, it means it's 0. 52, it's the filled pulse 0 alpha. So it's 0 alpha. 0 alpha means it's the qubit value 0 which is being sent from the LSNT. Okay, for this time slot. For this time slot, 50 to 53 alpha because it's high. 52 to 54 again alpha, it's the decoy pulse for the monitoring line. 55 to 56 again it's 0 0, it's a null value. And the 56 to 57, 56, what is this? Alpha, then 0. So now what we are getting at the box side, for this pulse 0 alpha, because it is high photon pulses, mean photon number is high, so we are getting the exact replica at the bob side. So it is just for showing how we can utilize the opti system or any other tool for this kind of simulation to generate the key at the LS end and at the bob end. Then we can try for the classical communication process or the quantum classical, like the error correction, privacy amplification, to get the final key. So again 0 alpha was sent, 0 alpha we have received, then alpha alpha was sent, alpha alpha we have received, again we have sent the 0 0, so we are getting the 0 0, then the same thing we have got. So this is for the high mean photon number. The same way we at the DM2 and DM1, wherever we are having the higher pulses, we should get the click at the DM1. Okay, so 52 these two pulses are higher, so we are getting the higher sequence here, and this pulse is overlapping with this one, so we are getting the full sequence here. For this click, this kind of click sequence, we should not get the detection at the DM2. If we are getting the detection at the DM2 also, it means our visibility index formulation is going below threshold, and we have to discard this communication. So this is the post processing steps for the cow protocol, ALS bob shifting process. Whatever the raw key we are getting, we have to apply the shifting process. So wherever we are not getting any key, we have to discard that communication. From the shifted process, we have to estimate the Q bar. If it is within the threshold, then we have to apply for we have to undergo for the error correction process. After error correction, some key may be leaked to the E, so we have to suppress that information. For this, we have to undergo the privacy amplification process. So the top edge hash function is being used for the privacy amplification, and finally we are getting the secure key. So based on this raw key, we have made our Python code, and finally we are getting the final secure key at both the end. Okay. Now coming to the prominent attacks in this domain, suppose we are having the beam splitter attack. So in this process, suppose some Eve is placing some beam splitter. So if it is placing the 5:95% beam splitter, so the 5% information will go to the Eve node, and the 95% information will go to the Bob's node. So when we have tried with the 5% beam splitter experiment, so at the Eve side we are getting very nil sort of detections, because already this is the weak coherent pulse, very weak signals are coming. So with the 5% we are not getting any good detection at the Eve side. So with this ratio, Eve is not getting any useful information. So this attack is futile for the low splitting ratio. Suppose it is increasing the splitting ratio more than 5%, 10%, 15%, 20%. In that case, what will happen? So 20% information will be gone to the Eve. So we are having a loss profile of the system, because the system जब एक पर्टिकुलर टाइम पे काम कर रहा है, हमें पता है कि हमारे 100 बिट भेजी थी, 20 बिट आना चाहिए, अब अचानक से उसके 20 बिट की बजाय 5 बिट आने लग जाए, so it means there is unusual loss. Unusual loss, how it has happened? It may be some Eve. So in that case, we can for the high splitting ratio, loss visibility index Q bars are affected, and Eve may be exposed. And this attack is again, it is effective, and this attack is effective when we are having the multi photon pulses. When we are having the single photon pulses, this attack is not effective. जब आप एक के ऊपर एक चीज को सपोज रखा हुआ है, आपने एक को लिया, तो आप ईव के पास ये ना कि जो बॉब के पास इंफॉर्मेशन वो मेरे पास भी की हो। यदि एक के ऊपर एक रखा, एक ईव ने ले लिया तो एक बॉब के पास चला गया, सेम ही इंफॉर्मेशन उसके पास गया, इन दैट केस इट इज इफेक्टिव। सपोज एक ही जा रहा था, ईव ने एक ले लिया तो वो तो ब्लैंक हो गया, in that case bob will not have any key. So eve might have got some key, but that key is irrelevant because bob is not having the key at that location. So in case of multi-photon pulses, because so that's why the multi-photon pulses are the killer of the security of the any qpd system. So we have to avoid the multi-photon pulses. Now coming to the intercept and resend attack, in this whatever the communication is going to the towards the bob, eve is measuring those communication with using the same setup as the ls is having, and then again it's resending, preparing that communication again same as the ls and sending towards the bob end. So when we have tried this communication using opti system and we have done the experiment, so in this case this was the ls communication 01. So I will just take the time to have the understanding. It's the bit 0, then 1, then 1, then 0, 0, then 1, 1, then 0. 0, 1 means it's the 0 pulse, 0 qubit. 1, 0 means it's 1 qubit, it was sent from the LS end. Again 0 means again the 0 pulse was sent. 1, 0 means 1 was sent. 1, 1 means it is decoy pulse for the monitoring line, for the measurement of the for the detection of the eve's activity. Then the 0, 1 again 0. So what eve has detected here, it because it's using the same setup as the ls is having, so it's detecting perfectly. Because of the channel loss, because of the channel loss, okay, 1, 0, for the 0, 1, because of the channel loss, this bit was lost, so it has got the 0, 0. This 0, 1, it's getting 0, 0. For this 1, 0, it is getting the perfect bit. For the 0, 1, again it's getting the perfect bit. Correct bits have been shown in the 0, 1 green color. Wherever there is a bit loss, we will get the 0, 0. So now this communication has been intercepted by the eve and it is perfect. Whatever it has got, it is correct. But when it's preparing the pulses again and sending towards the bob, because of the because two lasers are not same, eve eve is also having the laser in the resend module. What it's having the it's having the detectors at the intercept module, and then whatever the detection it has got, it is sending through the laser module. So it is having the same module, same setup as the ls is having, and this is the same setup just as the bob is having. Okay, so eve is having both the setup, bob setup and the ls setup. But because this cw laser, any two lasers, they are not perfectly the same. Whatever you do, it's not perfectly the same. So because of this thing, there will be some qbar will be generated, and when it's sent to the bob, so whatever the pulse it has sent, 0, 1, 0, it's getting the 0, 1. There is qbar 1, 0 it was sent, it is getting the 0, 1. Again for this position 0, 0, 0, 0 was sent, somehow because of the channel error it is getting the 0, 1. So we are getting a lot of qbar in case of intercept and resend attack. It's beyond the threshold, it's more than threshold. So in this case this attack is not effective. So because the qbar is increasing beyond the threshold, so the ls and bob will come to know we are getting the qbar beyond threshold, so we have to drop the communication. In that case they have to drop the communication. So we have seen they have applied the intercept resend attack, but it is exposed. So now coming to the sequential attack, it's the improved form of the intercept resend. Here what we are doing, we are targeting individual pulses, but here what it is doing, it is targeting groups of pulses, wherever we are getting uh, uh, where we are getting the consecutive detections like the 0 1 1 0 at the each side. Again the 0 1, it's a detection 0 1 1 0 0 1 1 0. So this is the consecutive detection. So in this case it's preparing the pulses and sending in the higher power. What it was sending is sharing here, suppose 85 dB loss was there at the attenuator at the Alicent. So the Bob E was also sending preparing and sending in the 85 dB loss. But here you want that whatever the pulses it's getting, it should be detected at the bob end. So it's whatever the pulse it's capturing, it's sending with the high power. Because of this high power, the bob will also detect the same sequence, and for the some sequence wherever it is not getting the consecutive sequence, it will remain silent eve. So in this case what happens, some pattern mismatch is there, unusual pattern will come because the eve is active on some time kind of bits and remaining it's silent on some kind of bits. So it's so pattern is unusual pattern. So with the use of pattern analysis we can identify this kind of attack. So this attack is effective, but with the use of AIML or the pattern analysis we can identify such kind of attack. So attack may be foiled by the pattern analysis. Q bar and visibility index are also not adversely affected much because we are whatever the bits it's getting, it's sending it in the proper way, and we are getting the proper we are not the Q bar we are not generating here. So when we compare these attacks, beam splitting ratio, its attack effectiveness is low, intercept again low, but its effectiveness is high, it's medium, less Q bar increase is there, visibility index almost same, but we are getting the pattern disturbance. With the help of pattern analysis, we can foil this attack attempt also, we can identify this sequential attack also. So now coming to the DPS differential phase shift, the cow was based on the time bin encoding. We were sending the pulses in the time bin format. Here the pulses we are sending, we are generating the key with the phase difference. So suppose this is the pulse trend which we are sending from the LSN. So what we will get at the bob end, this pulse and this pulse is having the phase difference of pi. So what is happening here? LS is sending the pulses. Yes. Hmm. Beam splitting. हम समझे नहीं, दोबारा बोलिए. हम्म हम्म हम्म, हाँ. तो BB84 में तो PNS अटैक उसमें ज़्यादा प्रोमिनेंट है. हाँ. नहीं मैडम, BB84 के दो वर्जन है, एक BB84 सिंपल, एक दूसरा डिकॉय BB84. जो सिंपल BB84 है वो PNS अटैक के लिए ससेप्टेबल है. PNS अटैक में पहले वो ये है कि उसको आइडेंटिफाई करना है कि उसमें फोटोन है या नहीं, तब वो उससे स्टील करता है. ठीक है, तो इसलिए क्योंकि जो भी उसकी बिट वैल्यू है वो डिस्ट्रीब्यूटेड नहीं है. BB84 के केस में देखेंगे, सपोज कोई पोजीशन है उसमें H आ रहा है या V आ रहा है, वो उसी बिट में कंटेन है. इधर पर क्या है, काउ के केस में वो 2 बिट में मिला के बन रहा है। हाँ, तो इसलिए ये पीएनएस से थोड़ा सेफ है और वो पीएनएस के लिए ससेप्टेबल है। दैट्स वाई इसका जो नेक्स्ट वर्जन है डिक्वाय स्टेट BBAT4 वो मार्केट में आया है कमर्शियल डोमेन में, और उसी पर ही एक्सपेरिमेंट हो रहा है। हाँ, तो चाइना का भी जो मिशेस सैटेलाइट का एक्सपेरिमेंट है वो डिक्वाय स्टेट BBAT4 पर किया गया, वो मच मोर सिक्योर है इन केस ऑफ प्लेन BBAT4। हाँ, ठीक है। तो इसकी इन अटैक्स में जो मोस्ट प्रोमिनेंट अटैक है वो सीक्वेंशियल अटैक है, क्योंकि इसमें ऐसा किया ना कि उसने आप कोई कम्युनिकेशन आ रहा था, ठीक है, तो उसने देखा कि कहाँ पर मैक्सिमम क्लिक आ रहे हैं मेरे पास, एक ऐसा उसने स्लॉट सर्च किया, उस स्लॉट को जहाँ पर उसको मैक्सिमम क्लिक 5 6 10 मिले, उसको उसने हाई पावर के साथ में मीन फोटोन नंबर ज़्यादा के साथ में बॉब की साइड भेजा। यदि आप ज़्यादा पावर के साथ आप उसको भेजेंगे तो जो आपने भेजा था वही बॉब को एग्जैक्टली मिलेगा। तो इससे क्या हुआ कि जो भी, और जहाँ पर उसको श्योर नहीं था वहाँ पर वो साइलेंट हो गया, उसने कुछ भेजा नहीं, तो उसको तो वो लॉस के रूप में कंसीडर कर लेगा बॉब कि मेरे को लॉस हो गया। जो भेजा था एग्जैक्टली वो मिल गया, तो इट मीन्स क्यूबर आपका जो क्वांटम बिट एरर रेट है वो कम हो गया, विजुअलिटी इंडेक्स कम हो गया। तो पर इस केस में एक लॉस ये हुआ कि एक पैटर्न आपका अनयूजुअल पैटर्न हो गया, कि कहीं पर भरा है फिल्ड है, कहीं पर ब्लैंक है, तो वो पैटर्न एनालिसिस के थ्रू इस अटैक को आप यू कैन आइडेंटिफाई। ठीक है, सो काउ प्रोटोकॉल वाज बेस्ड ऑन द टाइम bin. Differential phase shift protocol is based on the phase difference of the pulses. So here we are identifying the phase differences of the pulses. So it's sending the pulse train from the LS end. So here it's embedding the information, phase information using the phase modulator and sending over the quantum channel. Here the setup is something like that way. Whenever it's getting the pi phase difference, then one detector will click. Whenever it is having the zero phase difference between the consecutive pulses, then the detector 2 will click. So for example, suppose this is the pulse train we are getting. First pulse is high, then low, then high, something like this way. So the phase difference, how we will be having? So we will differentiate between the previous and the next one. So 0 pi, what is the difference? Here it is the pi. 0 0 0, 0 pi pi, pi, both are high, so 0, pi 0 pi, 0 0 0. So detector 1, which is meant for the pi phase difference, so it will click on the pi phase difference, click click click. Detector 2, it will click on the 0 phase difference, so it will show the click here. So in this way both the detectors are generating some key. This is the raw key. In the post processing steps, Bob declares time slots for the clicks. Bob टाइम स्लॉट सिर्फ बताएगा कि किस किस स्लॉट में मेरे को क्लिक मिला है। इट विल नॉट टेल कि मेरे को डिटेक्टर 1 में क्लिक मिला है या डिटेक्टर 2 में क्लिक मिला है। यदि वो डिटेक्टर 1 और 2 दोनों को बता देगा, देन द की इंफॉर्मेशन विल बी एक्सपोज एंड द ई विल आल्सो कम टू नो। सो इट विल ओनली टेल द टाइम स्लॉट। टाइम स्लॉट उसने ये नहीं बताया कि मेरे को पाई मिला कि जीरो मिला। तो इससे जो ईव है वो गेस नहीं कर पाएगा कि उसको पाई हुआ कि जीरो हुआ, तो वो इसको प्रॉपरली रिकंस्ट्रक्ट नहीं कर सकता है। ठीक है, तो अभी हम इसको आगे देखते हैं। सो एल एस की रिस्पेक्टिव फेज डिफरेंस फॉर द की जनरेशन। बॉब ने डिक्लेयर किया कि मेरे को इस टाइम स्लॉट पे क्लिक मिला है, सपोज उसने बोला कि मेरे को इस पे मिला। ओके, सो तो एल एस ने ये सेंड किया था ये पल्स ट्रेन। तो इस पल्स, सपोज इसने एक क्लिक मिला, तो ये भी इसने बोला कि मेरे को यहाँ पर क्लिक मिला लेकिन ये पाई था। So ls will also generate the key its own end. तो 0 पाई का डिफरेंस ls रखेगा, उसको भी पाई पता पड़ गया। इस पे क्लिक मिला, उसने देखा कि ls ने भी 0 रख लिया। ठीक है, तो इस तरीके से एलिस और बॉब दोनों ने एक एक की अपना जनरेट कर लिया, ये रॉ की हो गया। अब इस रॉ की को, अब इस रॉ की में कुछ एरर हो सकता है, क्यूबर हो सकता है, तो क्यूबर एस्टिमेट करेंगे पहले, यदि विद इन द थ्रेशोल्ड है तो आगे प्रोसेस करेंगे, फिर नॉट विद इन द थ्रेशोल्ड देन इसको डिस्कार्ड कर देंगे, और जो भी उसमें एरर होगा जितना, उसको वो एरर करेक्शन मेथड के थ्रू करेक्ट करेंगे, एंड फाइनली दे विल apply the privacy amplification, and finally they will get the secure key. So the main difference is that the shifting stage, after the shifting stage, for both the cow and DPS, process is same. The same thing is happening with other protocols also. Up to shifting stage is the main crucial thing. After that, everything is same. So now coming to the simulation result for the DPS protocol. So this was the pulse train sent from the LS end, and this is the phase information. Okay, so this phase information was sent from the LS end. So with use of this phase information, Bob is getting the click. So suppose from this to this, okay, okay, so this is 0 to 4. Here are the two pulses. So 0 0, because this is the both the high, so it will get the click here. Once again, okay. Blue represent the 0 phase and red represent the pi phase. Okay, so here for this pulse, because we are differentiating 2 with 1, so here we have to get the click, because the phase difference is, for this sequence the phase difference is 0, because both are the high, so it is getting the click here. Again, when we compare this pulse with this, again the phase difference is 0, so again it's getting click here. For this time slot 2 to 4, again we are getting the click, phase difference is 0, we are getting here. Now here when we compare this to this, because it was the pi, now it is 0, so it should get the click at the red end, pi end. See, it is 0 phase, it is the pi, so the phase difference is pi. So in this case detector D1 will click, it is clicking. Wherever there is a change, suppose here is the change, so here we are getting the click. Okay, the same way here we are getting the phase difference, so this time slot will click. It's okay, madam, should I proceed? So wherever there is a phase difference, it's getting the click here. This is the DPS result for the high power. Whenever we are having the high power signals, so we are getting almost clicks for the all the pulses. So we are getting for every pulse we are getting the click either on this or this. Both are, when we combine both, we are getting the clicks for all the pulses. Now, but we have to work in the low power domain, mean photon number very low. In that case, if we are having a very low mean photon number, so many photons will be lost during the communication. In that case, we will get the sparse clicks. So suppose 40 to 60, okay. So this is the, we are getting the QR 50 here we have to see the 50 how much we are getting. 50, is 50 is 0. Okay, so when we have the low power, then we are getting the sparse clicks, otherwise we are getting the clicks for every event. So finally we have to process this kind of raw data to get the secure key. So now coming to the beam splitting attack simulation result. So suppose we in case of low splitting ratio, attack is ineffective. At high splitting ratio, unusual loss happens and attack is identified. Again the same case is the in case of cow. In high mean photon number, the attack may be dangerous. If you are having the high mean photon number, again the same scenario, then this attack is dangerous. Now coming to the intercept and descent attack, it's having a very peculiar phenomena. Suppose Eve detects a phase difference at time t. Eve is detecting a phase difference at time t, but it has to resend also. यदि इसको in case it has to resend, then it has to make the 2 pulses. Okay, so it will make the 2 pulses here with the phase. Suppose it's getting at the click at the pi end, then it has to maintain the pi phase difference here. But when this photon travels to the other end, this photon may interfere with this one also, but this is not having the information of this thing. So because of this thing, the inherent Q bar 20 to 30% will be generated. समझ में आया मैडम? एक फोटोन आपको मिला, आपको सपोज डिटेक्टर D1 पे क्लिक हुआ, आपको पाई फेज डिफरेंस मिला, तो पाई फेज डिफरेंस किसके बीच में? इसके और इसके पहली वाली पल्स के बीच में. इसके और इसके बीच का पाई फेज डिफरेंस नहीं है, लेकिन आप जब जनरेट करके सेंड करेंगे उसको बॉब के एंड में, तो आपको तो पूरा पल्स ट्रेन बना के सेंड करना है, क्योंकि ये फोटोन आगे वाले से भी इंटरफियर कर सकता है. ठीक है, अब आपके पास ये इन्फॉर्मेशन नहीं है, सिर्फ आपके पास ये इन्फॉर्मेशन है, तो आपके पास आधी इन्फॉर्मेशन आधी नहीं है, तो आपको लेके बना के पूरा भेजना है. तो इन केस जब आपके पास इन्फॉर्मेशन ही नहीं, आप इसको पॉपुलेट करेंगे अपने हिसाब से, तो ऑब्वियसली उसमें क्यू बार आ जाएगा. तो यही सेम चीज़ यहाँ पर हो रहा है. तो इसलिए वो जनरली जो क्यू बार है 20-30% उसको मिलता है, और वो बियॉन्ड थ्रेशोल्ड है, इसलिए अटैक भी स्पॉइल हो जाता है. तो ये इसका क्या कहते हैं कि हमारा सिमुलेशन है. एलिस साइड से कुछ डेटा आया, ठीक है, और हाँ ये ईव की साइड में इसने उसको मेजर किया, क्योंकि ये वीक कोहेरेंट पल्सेस है, कहीं कहीं पर कनेक्ट इसको क्या कहते हैं कि क्लिक मिलेगा, कहीं पर नहीं मिलेगा. ठीक है, तो जहाँ जहाँ पर क्लिक मिला, ये सपोज ये रेड वाला क्या प्रेजेंट कर रहा है, रेड रिप्रेजेंट 0 फेज डिफरेंस, दिस इज पाई फेज डिफरेंस. तो इस क्लिक पर इसको एक क्लिक मिला है इस पोजीशन पर, तो ये जो 0 फेज डिफरेंस ये बता रहा है, ये इसका और इसके बीच का बता रहा है, इस पल्स का और इसके पहले वाली पल्स का. अब लेकिन जब इसको सेंड करना है, तो इसको पूरी पल्स ट्रेंड बना के सेंड करनी है, लेकिन इसको आगे वाले का नहीं पता है क्या मेरा फेज डिफरेंस था. जब आगे वाले का नहीं पता है, इन दैट केस क्या करेगा, उसको वो एम्बेड करने की कोशिश करेगा. जब एम्बेड करने की कोशिश करेगा, तो उसमें क्यू बार आ जाएगा. तो जो भी पल्स है, कोई बात नहीं, ठीक है, ब्रेक कर लेते हैं सबको. सर मैंने पूछा, सर ने बोल दिया. हेलो, हाँ, तो मैडम क्या हुआ, बाई लक हमने इधर पर कॉन्जिक्यूटिव पल्स में, हमारे पास कॉन्जिक्यूटिव पल्स में हमें क्लिक मिला है बाई लक. तो इस केस के हिसाब से इसके पहले वाले का भी इसको फेज डिफरेंस पता है, और इस वाले को इसका भी पता है. तो इसलिए इसने क्योंकि ये 0 फेज डिफरेंस है, तो 0 फेज डिफरेंस ये तो हाई रखें या लो रखें, 0 होना चाहिए. तो सपोज मैंने यहाँ से स्टार्ट किया, ये पाई का फेज डिफरेंस आ रहा था, तो इसके पहले क्योंकि 0 फेज डिफरेंस है, तो पाई का पाई ही रह गया, इसके आगे भी फिर पाई ही रह गया, क्योंकि दूसरे पे क्लिक मिला था. ठीक है, अब लेकिन जो ये बीच का टाइम स्लॉट है, इसका मेरे पास कोई इन्फॉर्मेशन नहीं है, तो इसलिए मैंने, अब मेरे पास कोई इन्फॉर्मेशन नहीं, मैं जीरो रखूँ पाई रखूँ क्या फ़र्क पड़ता है, तो मैंने इसको हायर पे ही रखा। लेकिन जब ये फोटोन उधर जाएगा बॉब एंड पर, तो ये दोनों इंटरफियर करके कुछ इंफॉर्मेशन निकालेगा, ये वाला करके कुछ निकालेगा, पर लेकिन ये वाला जो फोटोन है ये इससे भी इंटरफियर कर सकता है। अब इससे इंटरफियर कर सकता है, लेकिन ये जो इन्फॉर्मेशन मैंने डाली थी ये मैंने एम्बेड की है, अपने आप गेस मारा है, गेस किया है। तो अब इस गेस की वजह से उसका क्यूबर एक बियॉन्ड थ्रेशोल्ड इंक्रीज हो जाएगा 20 to 30%। इट्स थ्योरी ये इंक्रीज कर जा रहा है, और द सेम थिंग वी हैव ऑब्जर्व इन द सिमुलेशन रिजल्ट आल्सो। ओके, तो इसका ही बीम स्प्लिटिंग, देन इंटरसेप्ट डिसेंट, देन द सीक्वेंशियल। अब इसमें क्या है कि इसने क्या काम किया कि सपोज कोई एक इंडिविजुअल क्लिक्स भी आता है तो उसको भी सेंड करने की कोशिश करता है, लेकिन सीक्वेंशियल अटैक में क्या काम करेगा, जहां पर भी उसको कॉन्जिक्यूटिव क्लिक्स मिल रहा है, ओनली दोज क्लिक्स इट विल सेंड, जहां पर उसको स्पार्स क्लिक कुछ मिला वहां पर वो साइलेंट हो जाएगा, उधर पर वो पल्स बना के भेजेगा ही नहीं। तो इससे क्या होगा, अगेन जब आपको एक चंक मिला, चंक को आपने भेजा, तो आपके पास ज़्यादा चांस है करेक्ट बिट आने का, ठीक है, और बाकी जगह आप साइलेंट रह गए। लेकिन अगेन वही सेम प्रॉब्लम सीक्वेंशियल वाला होगा कि जो हमारा उसमें भी स्पार्स क्लिक्स पैदा मतलब स्पार्स पैटर्न पैदा होगा, अनयूजुअल पैटर्न पैदा होगा। It's a sequential attack. It's again the modified form of intercept resistant. E waits for the consecutive detection and then prepare pulse train and send to the bow. In this case, less chance of Q bar increase. In simulation, Q bar is still around 10 to 15%, and communication can be aborted because our threshold is around 5%. It is increasing beyond the threshold, so we can drop it. And the pattern analysis may be used to detect such kind of attacks. यदि इससे नहीं तो नाउ वी हैव द टू प्रोंग्ड स्ट्रेटजी, आइदर थ्रू क्यू बार इंक्रीज और थ्रू द पैटर्न एनालिसिस। यदि किसी एक, बिकॉज वी हैव टू गेट द डिटेक्टेबल डिस्टर्बेंसेस। क्यूकेडी का मेन प्रिंसिपल यही है, कोई यदि किसी ने कुछ आपके चेंज कर दिया, आपको डिटेक्ट ही नहीं कर पाए, तो फिर सिक्योरिटी गॉन। ठीक है, आपको डिटेक्ट करना है, डिटेक्ट चाहे क्यू बार की फॉर्म में करें, चाहे विजिबिलिटी इंडेक्स की फॉर्म में करें, चाहे लॉस की फॉर्म में करें, या अनयूजुअल पैटर्न की फॉर्म में करें। सपोज कल की डेट में रिसर्च ऐसी एरिया मूव कर जाती, कोई नया टाइप का अटैक्स आ जाता है, क्वांटम मेमोरी के साथ कुछ अटैक्स आ जाता है, यदि हम उसको अटैक को आइडेंटिफाई नहीं कर पा रहे हैं तो क्योंकि सिक्योरिटी में भी कौन, ठीक है ना। तो इन दैट केस वी हैव टू अप्लाई डिफरेंट टेक्निक्स। So this is the final result for the sequential attack. तो जहां पर भी इसको ये कंजिक्यूटिव क्लिक्स मिलता है वहां पर थोड़ा पल्स ट्रेन को हायर कर देता है, हाई पल्स पावर के साथ भेजता है। हाँ सॉरी, नो नो ऐसा नहीं है। अब ऐसा है कि सपोज मैं और आप आपस में बात कर रहे हैं, ये सर सुन रहे हैं, ठीक है, तो जो आपने इंफॉर्मेशन मेरे को, क्यूकेडी का मेन प्रिंसिपल ये है कि यदि हम आपस में बात कर रहे हैं, इतनी वीक वॉइस में बात कर रहे हैं कि सपोज इन्होंने कुछ सुन लिया, तो उस जगह पर इतना वीक है वो कि इन्होंने वो इन्फॉर्मेशन ले ली, तो वहाँ पर ब्लैंक स्लॉट आ जाएगा या उधर पर कुछ एरर जनरेट हो जाएगा। ठीक है, और जब आपके पास कोई, जो आपने पल्स ट्रेन मेरे को भेजी थी, मैंने यहाँ पर बैठ के पल्स ट्रेन सुनी, ठीक है, हम आपस में दूसरे चैनल के थ्रू क्यू बार कैलकुलेट करेंगे कि आपने क्या मेरे को भेजा था और मेरे को क्या मिला। ठीक है, यदि उसमें कुछ एरर आ गया है, एक बियॉन्ड थ्रेशोल्ड चला गया है, तो हम कम्युनिकेशन को वहीं पर ड्रॉप कर देंगे। हाँ, एरर नहीं, करेक्शन भी है। यदि विद इन द थ्रेशोल्ड है तो हम ट्राई करेंगे उसको करेक्ट करने का। यदि उसमें इतना एरर आ रहा है कि हमें लग रहा है कि ओके ये मतलब बियॉन्ड थ्रेशोल्ड आ रहा है, मतलब उसने कुछ इन्फॉर्मेशन पक्का ले लिया है, तो इन दैट केस हम उसको ड्रॉप करेंगे। अब क्या है कि जो डिवाइसेस लगी हुई हैं वो इम्परफेक्ट हैं, ठीक है, तो एक उसका इनहेरेंट क्यू बार तो आता ही आता है, क्योंकि हमने बोला कि हमें आइडियल फोटोन सोर्स चाहिए। ठीक है, आइडियल फोटोन सोर्स मतलब क्या, सिंगल फोटोन सोर्स। हर एक पल्स में एक एक फोटोन आना चाहिए, ठीक है, आपके पास बोर्ड नहीं है ना? हाँ, हाँ, तो हर एक पल्स में एक एक फोटोन आना चाहिए, लेकिन अब उसमें एक फोटोन, क्या कहते हैं कि एक फोटोन, सिंगल फोटोन सोर्स बनाना, इट्स अ टफ प्रॉब्लम, बिकॉज, हाँ, प्रैक्टिकल पॉसिबल, हाँ, तो इसलिए उसको, हाँ, इसको डाउन करते हैं। अब तो इसलिए वो मीन फोटोन नंबर, मतलब पूरे पल्स ट्रेन का जो मीन फोटोन नंबर है, वो बहुत ही कम रेंज में रखते हैं, 0.1, 0.2। तो मल्टी फोटोन पल्सेस आने का प्रोबेबिलिटी ही किल हो जाए। सिग्नल टू नॉइस रेशियो, नहीं, हाँ, तो अब ये की है कि आप किस टाइप का, मतलब कम्युनिकेशन करना चाह रहे हैं, आपको क्या, बहुत ही मिनिमम की के साथ भी आप, वो, मतलब कि सस्टेन कर सकते हैं, इसलिए आप, कई कई क्यूबरी सिस्टम से जैसे चाइना में लगा हुआ है, तो वो 10⁻³ बिट्स पर सेकेंड जनरेट करता है, बिट्स पर सेकेंड, बिट्स पर सेकेंड। तो इसका -3 का मतलब हुआ कि आपने 24 घंटे लगाया, यदि आप 10⁻³ सेकेंड के लिए कम्युनिकेशन करेंगे तो एक बिट आपको मिलेगा, मतलब इतना इसका स्पीड स्लो है कि, हाँ, बहुत कम हो गया वो, तो मतलब ये है कि फॉर द प्रूफ ऑफ कॉन्सेप्ट, फॉर द, कि हम कितना डिस्टेंस तक जा सकते हैं, क्योंकि फोटोन आपने यहाँ से सेंड किया और उसके चैनल पे लॉस है 0.2 dB पर किलोमीटर का। सिक्योरिटी पर्पस के लिए, हाँ, बिल्कुल, स्ट्रेटजिक कम्युनिकेशन, ठीक है। चलो भाई, चाय वाय पी लो सब। So welcome back. So this is the attack summary for the DPS, as I have explained earlier also. In case of beam splitting, its effectiveness is very low, because when we are having the very less beam splitting ratio, we are getting very less information at the event. If splitting ratio is higher, then the unusual pattern loss will happen in the communication. If unusual loss is happening, it means some attack is there. In case of this indication, Alice and Bob both will drop the key, drop the communication. Then coming to the intercept resend, again it's low effectiveness, because we are getting the Q bar around 20 to 30%, which is very above, well above the threshold around 5%. So in that case also the communication will be dropped. In case of sequential attack, Q bar is not increasing that much, but it is still increasing 10 to 15%. So it is also over the threshold. In that case also we can drop. And the second parameter, second strategy can be the unusual pattern. If we can observe the unusual pattern, in that case, with both the help of both the strategy, we can counter this attack also. So now coming to the a different set of QKD protocol. Earlier we were having the LS bomb. So from the attack angle, a attacker can attack at the LS end, attacker can attack at the bob end also. So the bob end, many kinds of attacks are there, like the detector control attack, detector efficiency mismatch. Okay, so now the researchers have thought that we should immune the detector side from such kind of attacks. So to immune the communication from the detector side from the attack, so this strategy they have devised. So this is the polarization based measurement device independent version, which we have studied. So here we are having the laser, then we are having the polarizer. Polarizer means just like the BB84, we are encoding the bits same as the BB84 HVDA basis, and at the bob end also we are doing the same. Then both the things are being sent to the Charlie. Charlie is a independent unit, untrusted unit. We are not trusting on that device. So it means if it is a Eve also this Charlie, so then in that case Eve should not having any advantage, because we are not trusting on the Charlie. So based on both the pulses, Eve is detecting the incoming signals, and it's getting the detection at the respective detectors. So those detections are being disclosed by the Charlie to Alice and Bob, and then the Alice and Bob finally generate the key based on those detectors. So now coming to the truth table of this kind of detection. Suppose we are having the H and H polarized light from the LS and H polarized light from the Bob. Then in that case we will get the detection either at D1 or D3, D1 and D3. So in this case D1 and D3, Charlie will also come to know D1 D3. D1 D3 ये जो कॉम्बिनेशन है सिर्फ एच एच के केस में मिल रहा है. ओके, D1 D3 ये कॉम्बिनेशन सिर्फ एच एच के केस में मिल रहा है और किसी केस में नहीं मिल रहा है. तो यदि चार्ली को पता है कि मेरे पास D1 और D3 का कॉम्बिनेशन मिला है, मेरे पास टैग क्लिक मिला है, इट मीन्स दोनों एंड पर एच एच होगा, तो वो तो श्योर हो गया, उसके पास जानकारी हो गई. तो इसलिए हम इस पॉसिबिलिटी को किल करना चाहते हैं. दैट्स व्हाई वी आर डिस्कार्डिंग दिस कम्युनिकेशन. व्हेनेवर एच एच qubits are there from the LS and Bob, we are discarding this communication. The same case is with the VV. In case of VV, we are getting the D2 and D4. Again we are discarding, because जैसे D2 D4 में मिला, उसने समझ लिया कि वी कम्युनिकेशन सेंड किया गया था, एच को सपोज हम 0 से रिप्रेजेंट करें, वी को 1 से रिप्रेजेंट करें, तो क्योंकि इसके बेसिस पर ही एल एस और बॉब, यदि सपोज इस कम्युनिकेशन को हम एक्सेप्ट करते तो एल एस के पास 0 बिट हो जाता, बॉब के पास भी 0 हो जाता, और ये इसको भी पता है क्योंकि इसके पास D1 D3 पे क्लिक हुआ है। तो इस पॉसिबिलिटी को किल करने के लिए हम इस टाइप की कम्युनिकेशन जिसमें दोनों सेम क्यूबिट है डिस्कार्ड कर देते हैं। अब दूसरा कॉम्बिनेशन था कि एच वी और वी एच, तो इस केस में क्या है कि D1 D4 पर क्लिक हुआ, D1 D4 पर क्लिक हुआ, चार्ली को पता है कि ओके D1 D4 पर क्लिक हुआ, इसके पास एच है, इसके पास वी है, लेकिन अब इन दोनों यदि सेम बिट अराइव करनी है तो इनमें से किसी एक को फ्लिप करना पड़ेगा बिट को। वो फ्लिप कौन करेगा वी डोंट नो, बिकॉज दिस इज एम्बेडेड इन द एफपीजीए कंट्रोलर। कौन इम्प्लीमेंटर के ऊपर है, जो डिजाइनर है, कि किसको फ्लिप कराएगा, बॉब को फ्लिप कराएगा, एलिस को कराएगा, या किसी सीक्वेंस में कराएगा, या किसी टाइम के हिसाब से कराएगा, वी डोंट नो। तो चार्ली इज आल्सो नॉट नोइंग। तो इस केस को हम कंसिडर करते हैं फॉर द फाइनल की जनरेशन। द सेम थिंग इज हियर इन द वीएच केस आल्सो, कि अगेन Charlie is knowing that there is a VH combination, but who will flip we don't know. Charlie is not knowing. So ये combination सिर्फ एक्सेप्ट होगा, बाकी एक्सेप्ट नहीं होगा। ओके, ऐसे ही जब डी डी यहाँ से आता है तो चारों ही डिटेक्टर्स क्लिक हो जा रहे हैं। सो इन दिस केस वी आर डिस्कार्डिंग दिस टाइप ऑफ कम्युनिकेशन। ठीक है, इसी के बहुत सारे परम्यूटेशन कॉम्बिनेशन किए जा सकते हैं। कभी पोलराइजेशन पे कुछ डिफरेंट आपने एंगल लगाया, तो इस तरीके से बहुत कॉम्बिनेशन बनते हैं इसके। लेकिन आप इसमें देखिए कि आउट ऑफ दीज 8 कॉम्बिनेशन ओनली 2 आर सिलेक्टेड, तो इसमें की रेट बहुत कम हो गया। इन BBT4 के केस में क्या हो रहा था कि 2 में से एक बार 50% आप डिस्कार्ड कर रहे थे, यहाँ पर क्या हुआ 8 में से सिर्फ 2 कर रहे हो, मतलब 25% ही की आप निकाल रहे हो। तो इसमें की रेट अगेन रिड्यूस हो जाएगा। लेकिन इसका एक फायदा ये हुआ कि आपके डिटेक्टर साइड पे जो अटैक थे वो नलीफाई हो गए, आपका डिस्टेंस बढ़ गया। ठीक है, और दूसरा है जो सपोज बीम स्प्लिटिंग आपने अटैक, जो हमने अटैक अभी देखे हैं, तो अब बीम स्प्लिटिंग अटैक में सपोज हम बीम स्प्लिटिंग क्या है कि कोई ईव बैठ के कम्युनिकेशन को लिसन करने की कोशिश कर रहा है, यही हो रहा है ना। तो हम मानते हैं चार्ली ही ईव है, यही बीम स्प्लिटिंग लगा रहा है, इसके पास सारी इन्फॉर्मेशन है। तो क्या चार्ली निकाल पा रहा है कि क्या क्या की था? जब चार्ली नहीं निकाल पा रहा तो ईव यदि दूसरा कहीं दूसरी जगह बैठ के निकालेगा तो वो क्या ही कर लेगा। ठीक है, सो इन दिस केस इट इज सेफ, प्रोटोकॉल इज गिविंग अस protection from this attack. The same case is with the intercept resend also, because again it will suppose Eve is sitting here, it will first intercept, then resend to the Charlie. So we are assuming that Charlie is the Eve. Why it should take the headache for resending? It should only intercept. ठीक है, तो in that case also intercept resend attack is also getting failed. ठीक है, so this is given immunity from these attacks. So now coming to the one modified version of this MDI protocol, that is called the twin field protocol. In this protocol what is happening, so there is one effect that is called the Hongo Mandal effect. So उस so in for that effect we should have the indistinguishable photon from the LS and Bob. जो in realistic situation to perform and maintain MDI QPD is very hard, because from the both the side we should have the indistinguishable photon. और इतनी डिस्टेंस में indistinguishability मेंटेन रहेगी नहीं रहेगी we can't say. तो इसलिए from the practical point of view MDI QPD is very hard. So this twin field strategy has been devised. So इसका एक बेसिक वर्जन है फेज मैचिंग, that version we have done. So here is the ledger. It is same as the DPS protocol. DPS में क्या है, आप फेज डिफरेंस मेजर करते हैं. The same thing is happening here. It is encoding the phase modulation. Then there is a phase randomizer which is randomizing the phase, and then we are getting the detection at the D1 and D2. So suppose when both the phases are matching in the same basis, suppose 0 and pi, only in that case that communication will be taken when the basis from the both the sides are same. So this is the truth table. Suppose at the LS and Bob both are working at the x basis. X basis means 0 pi. In case 0, so LS phase is also 0, Bob phase is also 0. The phase difference is 0. And in other case, LS is having the phase difference phase pi, Bob is also having the phase difference phase pi, then the phase difference will be 0. Whenever we are having the phase difference 0, then the detector D1 will click. Whenever we are having the phase difference pi, detector D2 will click. So it means for one output we are having the two inputs. For one output we are having the two inputs. So this input will be this output will be broadcasted by the Charlie to the LS and Bob. Then whenever, so it will say that I have got that detection at the D1. So D1 means nobody will flip the bit because both are having the same phase. If it is D2, it means the phases are opposite. Suppose we are representing the 0 with the 0 bit, pi with the 1 bit. So to arrive at the same key, we have to flip some bit. Which one will flip? It depends on the implementer. But the question is, क्या इसके D1 के डिटेक्शन से चार्ली को सपोज D1 डिटेक्ट हुआ, क्या वो इन्फर कर सकता है कि उसको ये वाला फेज मिला था या ये वाला मिला था? क्योंकि दो इनपुट है, आउटपुट एक है. सपोज इसको D1 मिला, हमें ये है कि चार्ली को कुछ भी इंफॉर्मेशन रिवील नहीं होना चाहिए. उसको 1 मिला है, ये वाला भी कॉम्बिनेशन होता है, ये वाला भी हो सकता है. ये वाला हुआ तो 0 0 की बना, ये वाला हुआ तो 1 1 बना. ठीक है. तो इस केस में अगेन जैसे एमडीआई के केस में था कि चार्ली को कुछ भी रिवील नहीं हो रहा था, यहाँ पर भी चार्ली को कोई भी रिवीलेशन नहीं हो रहा है. तो अगेन दिस इज इम्यून टू द बीम स्प्लिटिंग एंड इंटरसेप्ट रिसेंट. इस केस में क्या हुआ कि आपका डिस्टेंस भी इंक्रीज हो गया, लेकिन ये दिस टीएफ इज वर्किंग ऑन द सिंगल फोटोन इंटरफेरेंस. सपोज एलएस और बॉब में किसी एक फील्ड तो आ रहा है आपके पास, एलएस का भी फील्ड है, बॉब का भी फील्ड है, पर एलएस की फील्ड में कोई फोटोन नहीं है, बॉब की फील्ड में फोटोन है, दोनों इंटरफियर करेंगे. तो इसमें फोटोन नहीं, लेकिन इसमें फोटोन है, पर फेज डिफरेंस है, फेज है उनके पास में. यदि एक भी फोटोन आया तो क्लिक आपको मिलेगा. तो इससे क्या हुआ कि आपका जो की रेट है इट इज बेटर देन द एमडीआई. पीएलओबी बाउंड को एक्सीड कर जा रहा है, ट्रांसमिटेंस स्क्वायर रूट ईटा हो जा रहा है इस केस में. ये टीएफ का एडवांटेज है. तो एडवांटेज क्या हुआ कि जो डिटेक्टर साइड के अटैक्स हैं वो आपने नलीफाई किए, इसका की रेट आपने बढ़ाया, और की रेट बढ़ा तो इट मीन्स डिस्टेंस भी बढ़ गया. तो इसीलिए दिस प्रोटोकॉल इज वेरी मच इन रिसर्च अक्रॉस वर्ल्ड. चाइना हैज डेमोन्स्ट्रेटेड अराउंड 1000 किलोमीटर लिंक फॉर द टीएफ, but their key rate is very low, 10 to power minus 3 secure key rate they have given. So now coming to the again the general thing, the beyond fiber, what are the options we are having? The free space quantum key distribution, then satellite based communication. So again these are the general points for the general audience I have written for this thing. So we are not requiring any physical fiber, wireless medium, line of sight communication is required. No licensing for the optical spectrum, so that's cheap. Ideal for the remote, mobile and hard to reach locations, mountain, desert, island, disaster zones. For the military communication, it is much more, it is very useful because we are having the hilly terrain, all those things. Suitable for long distance and global QKD using satellite. कि यदि आप सरफेस टू सरफेस कम्युनिकेशन कर रहे हैं तो बिकॉज ऑफ दिस एटमॉस्फेयर, तो ये दिस इज हार्ड टू अचीव, ज़्यादा डिस्टेंस नहीं कर सकते. बट आप सरफेस टू सेटेलाइट कर रहे हैं तो एटमॉस्फेयर तो 10 किलोमीटर तक ही है, उसके बाद आपको फ्री स्पेस है, मतलब वैक्यूम है. इन दैट केस आपका लॉस वगैरह बहुत कम हो जाएगा. लेकिन उसमें क्या है कि डिफ्रैक्शन बहुत इंपॉर्टेंट रोल प्ले कर रहा है, बीम स्कैटरिंग, एंगल्स, ठीक है. तो रैपिड एब्जॉर्प्शन attenuation loss in the space, low absorption attenuation loss in the space, vacuum above 6 to 10 kilometer height. Satellite is trusted node, we can assume as a trusted node, but right now this statement may not be that much valid because some मतलब कि cyber attack, through cyber attack we can't consider satellite as a trusted node, but for the general sense we have written that satellite is a trusted node, being out of reach for the tempering side channel. So drawback, line of sight alignment, turbulence and weather impact, preferred night operation क्योंकि it's a high background noise in the daytime. So, but currently the people are commercial companies are making the system for the daylight operation also. बट मैडम डे लाइट के लिए, हाँ अब लेकिन डे नाइट के डे टाइम के लिए भी दे आर मेकिंग द सिस्टम. हाँ, देयर इज वन कंपनी क्यूनो लैब, इट इज डेवलपिंग द सिस्टम फॉर द डे टाइम आल्सो. लिमिटेड सेटेलाइट विजिबिलिटी बाय द टर्मिनल. तो अब ये आपके ऊपर डिपेंड कर रहा है कि आपका सेटेलाइट किस जगह पर है, लियो पर है, जियो पर है, किस जगह पर है. यदि लियो पर होगा उसका स्पीड बहुत तेज है, कुछ समय के लिए आपके पास कलेक्ट की जनरेट होगा. यदि जियो पर है तो आपकी डिस्टेंस ज़्यादा है तो आपको बहुत कम की मिलेगा, लेकिन 24/7 आपके पास अवेलेबल है. नहीं नहीं, हाँ अभी तक जियो का नहीं हुआ है. हाँ हाँ अभी, हाँ तो सॉरी, हाँ हाँ हम्म हम्म हाँ नहीं, हाँ तो इसके ऊपर तो वैक्यूम है तो इसके उसमें लॉस बहुत कम होगा. तो जो भी, हाँ, जो भी कम्युनिकेशन जा रहा है वो आपका लॉस नहीं होगा. जैसे फाइबर का तो 0.2 dB पर किलोमीटर का है, तो उसमें लॉस नहीं होगा. लेकिन उसके दूसरे चीज़ें, बीम डाइवर्जेंस हो गया. हाँ बताइए. ओके ऐसा है, ठीक है ठीक है. तो अब इन केस वी आर सीइंग द फाइबर वर्सेस एफएसओ, तो अप्रॉक्स अप टू 100 किलोमीटर फाइबर इज मोर एफिशिएंट इन टर्म्स ऑफ की रेट एंड लॉस देन द फ्री स्पेस. जब 100 किलोमीटर के ऊपर जाते हैं डिस्टेंस ऑफ 1000 किलोमीटर एफएसओ लिंकेज 16 ऑर्डर मोर एफिशिएंट देन द फ्री स्पेस देन द फाइबर. फाइबर का ग्राफ ऐसा है कि 1000 किलोमीटर तक ये सॉरी फाइबर का लॉस जो है इस तरीके से हो रहा है, 1000 किलोमीटर 200 dB का लॉस हो गया. लेकिन फ्री स्पेस के केस में इट इज ओनली अराउंड 25 to 50 dB. तो हाई रेंज कम्युनिकेशन के लिए एफएसओ सेटेलाइट इज मच मोर सुटेबल. So now coming to the comparison table for this thing. Stability, optical fiber, it is having a high stability, free space low, satellite again the low, and the cost wise it's low, high, and satellite communication it's very high. but together all these technologies complementing each other towards a global network. They all have its own suitability, case to case basis. So in all the area we have to do the research, we have to make the systems. So again uh, satellite link configurations. So there are these options or scenario which can happen. So LS is there. In this case, LS is sitting at the satellite and sending the communication to the Bob at the ground station. Or LS is transmitter is here, receiver is at the uh, at the satellite. But in this case, uplink communication loss is much more, because it has to यहाँ पर ही वो इसका थोड़ा एंगल बिकॉज ऑफ दिस एटमॉस्फेयर इसका एंगल इंक्रीज कर जाएगा, तो बिकॉज ऑफ दिस एंगल इंक्रीमेंट increase in the angle, very less number of photons will be available at the satellite, or there are the LS and Bob here. So suppose it's sending, then it is reflecting it and it's getting at the Bob end. और ये इंटेंगलमेंट का सिनेरियो, सपोज यहाँ पर इंटेंगल्ड सोर्स है, इसने इसको शेयर किया एक पेयर इसको शेयर किया, या ऐसा कुछ सिनेरियो है कि ये इंटर सैटेलाइट कम्युनिकेशन हो रहा है, इसने इसको किया और फिर दोनों ने आपस में, तो इस टाइप का सिनेरियो पॉसिबल है, इंटर सैटेलाइट लिंक फॉर द मोर कॉम्प्लेक्स कनेक्शन. तो राइट नाउ इस टाइप का सिनेरियो ट्राई किया गया है मिसियस में. और दूसरा कनेक्शन फ्लाई बैक वाला उसमें उन लोगों ने किया हुआ. दूसरा ये तरीका है कि सपोज आपके पास दो ग्राउंड स्टेशन है, एक ग्राउंड स्टेशन के साथ आपने की के बनाया, दूसरे ग्राउंड स्टेशन के साथ के भी बनाया, दोनों ही की इसके पास हैं सैटेलाइट के पास में. फिर लास्ट में ये इसने क्लासिकल लिंक के थ्रू के प्लस के एक्स और के भी दोनों को शेयर किया. जब ये दोनों अपने आपस में इसके साथ की को एक्सऑर करेंगे, देन इट विल गेट द ईच अदर्स की, दे विल गेट द ईच अदर्स की, के भी इसको मिल जाएगा, इसको भी के मिल जाएगा, बोथ विल हैव. तो ये इस केस में क्या है कि ये सैटेलाइट एक सिर्फ LS is there at its end, and the Bob 1, Bob 2, both are at the ground station. Now again the LEO and GEO, where we have to place the satellite at altitude is 2000 kilometer. Here we are having 35,786. So all its relative motion is very high. Static for the equatorial, geo terminal, minimal for the inclined. ठीक है ना. Point PET system, it's a very complex system because it has to continuously point towards the it has to track the satellite. It's very simple because it's seeing at the simple one direction. Signal path loss is low, it's very high, 40 dB, and the time delay is also it's 7 millisecond around, it's 250 millisecond. So now coming to the mean photon number, in both the case mean photon number will be same because we are operating in the single photon or WCP range. Quantum pulse power will be also the same. Technology readiness level is high in case of LEO. In case of GEO, it's very low. And received photons are much higher in this case, it's much lower. Why? Because diffraction will be higher in case of this 35,000 kilometer traveling. So again, this is the calculation for the general people. So suppose we are having the beam divergence of 10 microradian, then in that case of the LEO, we will have the beam diameter of 5 meter. In case of GEO, we will be having the 360 meter. When we collect this power at the receiver end, so GEO will be collecting only the 0.00077%, and LEO will be capturing around 4%. So in this case, the key rate again will be very low. So now coming to the protocol suitability for the satellite free space. So currently BB84 and device BB84 has been are being used in the satellite domain. DPS, cow, MDI, QKD, they have not been used. They are difficult, also require the phase coherence between the consecutive pulses after atmospheric propagation. Cow, it is difficult, requires stable interference measurements and monitoring stable visibility. But ऐसा नहीं है कि ये किए नहीं जा सकते हैं. The people are trying with the DPS also. They can do with the DPS. They are difficult, but they are trying, and in future also, in future they might be also used for this kind of communication. So again, suitability for the media and suitable wavelength for the optical fiber, we are operating in the range of 1550 nanometer because it is having the it is having the lowest fiber attenuation. 1310 also people are using, but the attenuation is high in that case. In case of free space, people are working in the 50 nanometer. Again, the detector efficiency is high in this case. 15 nanometer provides better eye safety in the lower atmospheric scattering, and so the major experiment worldwide 23-24 China has demonstrated the TFQKD demonstration, and it was 1002 kilometer, but longest fiber distance it has been achieved, but it was very low, 10 to power minus 3 meters per second. Shanghai. Okay. Okay. Then it is the result of the Messier satellite. So is organizer is requesting. So I will wind up very fast. So for the Messier satellite, the major experiment which has been demonstrated, satellite to ground QKD distribution, longest distance entanglement distribution, intercontinental quantum secured communication, daytime also they have demonstrated for this thing. Now coming to the major security concept in the QKD area. So the practical security proof means about how secure protocol is a concept for infinite number of samples. Finite key analysis means how secure a particular implementation for finite number of samples. It is as a concept how much secure, it is as a implementation how much secure for a particular run. In this case, we target some security level, how much security guarantee this system is providing. So based on this security angle, security value, we have to compress in during the privacy amplification phase. So for I will just cover this one. So as the madam was asking how much maximum Q bar can be sustained by any protocol. So it depends on the formulation. So this is the formulation given by the Soren press scale. So in this is the secure key rate. 1 means the raw key rate was 1 minus FEC, error correction efficiency, HQ, whatever the error it is getting, because of this error how much randomness is being lost, and then the during the error correction, and because of this randomness how much because of this error how much information is gained by the E, and the delta is the finite key penalty because we are not considering the infinite samples. So when we solve this problem for the under ideal condition n is equal to infinity but the infinite number of samples, so the maximum Q bar it's coming 11%. So the maximum Q bar is coming 11% in case of ideal scenario also. So this is the ideal limit. So beyond this limit, suppose you are getting the 12% Q bar, you will not get any key, any secure key. If you are doing that thing, it means security may be compromised. And finally, the Q bar threshold for the cow protocol, for the ideal scenario, it is coming around 50%. For the practical scenario, suppose we are having the data block of 10 to power 9, visibility index 0.98, epsilon security, whatever our target is 10 to power minus 10. So it is the practical threshold is approximately 23.8%. and for similarly for the DPS, it's coming 11.5%. So we have seen the motivation for the QKD, various components, different QD protocol, attacks and communication media. Cow DPS both can detect attacks like the beam splitting, IR and sequential. With the MDI and 12 field, we are mitigating the attacks over the detector side. But now the current research is focused on the device independent QPD systems, so that we can mitigate the attacks at the LS side, source side, and the Bob side both. And for the practical scenario, for the practical to make it to have the global practical internet scenario, quantum internet scenario. So long distance communication like through either satellite QKD, LEO based QKD, or TFQKD. It's also research is going on in these areas, device independent and the long distance communication, so that we can make this system practically more useful. So with this, I conclude my talk. Any question, answer? Thank you. Thank you. मुझे पता नहीं कितना समझ में आया, लेकिन क्योंकि ये थोड़ा इन्वॉल्व चीजें हैं, तो आप यदि क्योंकि इसको करने में भी हमें टाइम लगा। हाँ, क्योंकि पहले तो हम यही नहीं समझ पा रहे थे, कोई बिट गया तो कैसे वो लॉस हो गया वहां पर। ओके, कोई बात नहीं, कोई बात, ठीक है, ठीक है। एक्चुअली मेरे साथ तो ये था, मुझे लगा कि ऐसा ना हो कि
Thank you so much, sir. We are truly honored. We are truly honored, sir. So, for the beautiful presentation and insightful presentation on the topic QKD and the different protocols like DK, BB84 and so on. So, I now request Professor Kirti Gupta ma'am to kindly come and as a token of appreciation for the sir. Thank you once again, sir. And it is requested to all to please kindly come forward for a group photograph.